Problem number 5. Two counterfeit coins of equal weight are mixed with 8 identical genuine coins. The weight of the 2 identical counterfeit coins is different from the weight of each of the genuine coins. A pair of coins is selected at random without replacement from the 10 coins. And then a second pair is selected at random without replacement from the remaining 8 coins. The combined weight of the first pair is equal to the combined weight of the second pair. What is the probability that all 4 selected coins are genuine? Alright, well, let's take a look here. So, what we've got, I'm going to draw circles to represent coins. Pretty creative, huh? So 5, 6, 7, 8, 9, 10. So we have 10 total coins and they look the same, right? But 2 of them are counterfeit. So let's pretend like this one is counterfeit and let's say this one is counterfeit. Okay, so 2 of the 10 are counterfeit. So we're looking for the probability that, you know, if we select one and then we select another, we put them on a scale, and on one side of the scale, and then we select another one, and we put them on the other side of the scale. What's the probability that all 4 of those coins are genuine? All right. So let's look at the case here. Let's look at the case where they're all genuine. If it's genuine, I'll leave it white, and if it's counterfeit, I'll color it in. So the probability that the first coin that we draw is genuine is, you know, we have 8 genuine coins out of 10. So the probability that the first one is genuine is 8/10, right? And then, so we have 7 genuine coins left and 9 coins total left. So the probability that the second one is also genuine is 7/9. Okay. And then the other pair of coins. So if we didn't replace any of these coins, then the first one of the second pair. So we have 6 genuine coins left, and out of a total of 8. And then we have 5 genuine coins out of 7. So the probability of that happening, of getting all genuine coins, is, you know, when we multiply all these probabilities together. So it's 8/10 times 7/9 times 6/8 times 5/7. And if we simplify that, let's do that. So we got 7, we got 8, we got, alright, 7 and 8 here. And we can divide 5 into 10 and get 2. We can divide a 3 out of the 6 and the 9. Okay. And then these 2's will cancel. So we would end up with 1/3 is the probability. But you have to be careful because that's the total probability. That's the probability that all the coins are genuine out of all the possible combinations of coins that could come up. But what we're looking for is the probability that if the 2 sets of coins weigh the same, then what's the probability that all the coins are genuine? Okay, so we have to be careful. So this is actually the, you know, we're going to have 10 times 9 times 8 times 7 different arrangements of the 4 coins. Or I should say, possibilities for the 4 coins, okay, and so this is actually out of all of the possible coins, including when the pairs do not weigh the same. Okay, so like if we drew a genuine and a counterfeit, and then 2 genuine. Those would not weigh the same, so we don't want to include that in our probability, even though it would be included in this probability. So this is the probability out of the total. All right. So let's look at the other possibilities for the way that these coins could come up and weigh the same. So we know that the counterfeit coins are equal weight, and the genuine coins are all equal weight. So we could come up with a scenario where we draw a counterfeit first of all, and then we draw a genuine, and then on the other side we draw a counterfeit and a genuine. Okay. So what's the probability of that? Okay, so we draw the first coin, and there's a probability of 2 out of 10 that that is counterfeit. And so now we still have 8 counterfeits, or 8 genuine coins left, but we only have 9 total coins. And now here we only have 1 counterfeit coin left at this point, and we have 8 coins. And then finally we have, 7 genuine coins left out of 7 total, so it's just going to be a probability of 1. Okay, once you've drawn both the counterfeit coins, there are no counterfeit coins left, and so you get a 100% chance of drawing a genuine coin on the last draw. Okay, so that probability we could write out as 2 tenths times 8 ninths times 1 eighth times 7 sevenths, and obviously that's just 1. And 8ths can cancel, and this can become a 5th. So the probability is equal to 1 out of 45. Okay, but we have to, this is when you have 1 counterfeit and 1 genuine, and 1 counterfeit and 1 genuine. But there's a number of different ways they could come up. We could draw the genuine first, and then the counterfeit. Okay, and let's say over here we draw the counterfeit and then the genuine. Okay, or we could draw the counterfeit and then the genuine, and then another genuine and a counterfeit. And then let's see, over here we could draw a counterfeit, or sorry, a genuine and a counterfeit. And over here we could draw, let's see, we've got that. So the other possibility would be a genuine and a counterfeit. Okay. So there's actually 4 possible ways that those coins could be drawn in the order, that the order of those coins could be drawn. Okay, so we actually had to multiply this times 4. I see that for each case, the scenario, or sorry, for each case the probability is the same, right? You have, so here you have 2 tenths, and here you have 8 ninths, and here you have 1 eighth and 7 sevenths, right? So the probability of the scenario is the same, but there's 4 different ways that it could come up. So we need to take this times 4, okay? And then this ends up being 4 45ths, okay? So this is all the possible ways that we could get the 2 pairs of, 2 sets of coins weighing the same, okay? And that's what we want to find probability of. When those coins weigh the same, so the combined weight of the first pair is equal to the combined weight of the second pair. Okay, so that's what we're looking at. We're only looking at the probability of when this is true. Okay, and so what we can do is actually take the ratio of those probabilities. So we have a probability of 1/3 that they're going to be genuine, and that's out of the whole, all of the possibilities. And we have probability of 4 45ths that it's going to be, that we're going to have 1 counterfeit on each side. And so, and that's, again, I thought of all the possibilities. And so let's take the ratio, 1/3. So we want the probability that the 4 selected coins are all genuine. So it's 1/3 over 1/3 plus 4 out of 45. Okay. So we're going to have a complex fraction here. If we multiply through by, say, 45 on both top and the bottom, so if we multiply this by 45 over 45, that's just 1, so we're not changing the value. But we'll end up with 15 on the top, and then we have 15 plus 4 on the bottom, so that'd be 19. Okay, so that's our answer. Now another way we could have done it is just count the number of things here, number of ways. So the number of ways, you have eight choices for the first genuine coin, and 7 for the second genuine coin, 6 and 5. So this would be the total number of ways that we could get all genuine coins. And then the number of ways that this could come up, we got 4 of them, and there's 2 ways to get a counterfeit times 8 ways to get a genuine, 1 more counterfeit, and then 7 ways to get the last genuine coin. And we could just take the ratio of those. Let's see, it would be 8 times 7 times 6 times 5 all over 8 times 7 times 6 times 5 plus 4 times 2 times 8 times 1 times 7. Okay, 1 times 7. And if you you can factor out an 8 and a 7 here, and so you end up getting 30 over 30 plus, what is that, 8, 30 plus 8, which is equal to 15 out of 19. So you get the same thing if you count, instead of working with probabilities, you work with actually counting the number of ways that these different scenarios could come up. Okay. One thing too, if you want to look at all of the different ways that these coins could come up and include the ones that we don't really want, and just to check yourself to make sure that your that your probabilities are correct. You could look at the case here. We have 0 counterfeits. Here we have 2 counterfeits, 1 on each side. The other scenarios would be 1 counterfeit comes up total. Okay, and that would look like you get a counterfeit and then a real one, and then a counterfeit, and then 2 real ones. Or you could get your counterfeit one could go here, or it could go here, or go here. Okay, so you'd have 4 times 2 over 10 times what is that, 8 out of 9 times 7 out of 8 times 6 out of 7, right? And again, do a lot of canceling. So we have, what is this? This is 5. This could be 3, and this could be 2. And so that looks like we end up with actually, if I don't, I want to get 45ths are a little easier to work with. So actually, that comes out to be equivalent to 24 45ths, because I want to have the common denominator, and I got 45 up here, so it's a little easier. I want all these probabilities to add up to 1. So another case, and so I'm just filling out the rest of the cases. So the other case would be when you have 2 counterfeits, okay, but the sides don't weigh the same, so both the counterfeits would have to come up on one side, on one set. Okay, so these are just the rest of the scenarios. Okay, and here you can see that you're still going to get 1/45 just like we did out here, because we have 2 counterfeits and 2 real coins, but you only have 2 ways that they can come up on the same side, or in the same set, same pairs. So this is actually 2/45, and if we add up here I should not circle that so that you can tell which one's the answer. But if you add up 2/45, 24/45, 4/45, and this is actually 15/45, you should get 45/45. Okay, so you can see these are the other scenarios where they don't weigh the same. So you can see now why this probability is the probability that they're all genuine out of all the different possibilities.